Hello students, welcome back to JJ's physics class. In the last class, we have derived unimportant equations of motion, that is V is equal to U plus AT, also known as velocity time relation. Today, we are going to derive two other important equations, that is S is equal to UT plus half AT square is also known as position time relation, and V square is equal to U square plus 2AS is also known as position velocity relation. So first we are going to derive equations for position time relation. So before starting, let me give you brief explanation about this graph sheet. We already discussed this graph in the previous derivation, that is V is equal to U plus AT. As we know that we have plotted the velocity time graph. Time is along the x-axis and velocity is along the y-axis. Consider an object A which is having some initial velocity u, is moving under uniform acceleration and reach the position B having final velocity v. Let us consider that the object has travelled a distance s in time t under uniform acceleration a. We have discussed in velocity time graph, if we want to calculate the distance travelled by the object is equal to the area enclosed within OA, B, C. Thus, the distance S travelled by this object is given by area of OABC. We have learned that this is the shape of a trapezium or area of rectangle plus area of triangle. So, which is equal to area of rectangle plus area of triangle, which is equal to area OADC plus area ABD, which is equal to, what is area OADC? So, OA multiplied by OC plus area of triangle is half into base into height. So, half into AD times BD. Substituting the values, what is OA here? OA is nothing but U. So, OA which is equal to initial velocity. What is OC here? These two are parallel lines. So, OC which is equal to AD which is equal to time taken. And what is AD? Again it is T itself. But what is BD? How do we calculate that? So for that, we have the slope of this velocity time graph which is equal to BD divided by AD. We have already discussed that in the previous class. Now, what is slope? Slope of velocity time graph gives what? Acceleration, which is equal to BD divided by AD. But what is AD? We already learned that AD is equal to T. So, which gives A is equal to BD divided by T, or BD which is equal to what? A into T. So, what is the BD value? Which is equal to A into T. So, substitute the values here. So, the distance traveled S is equal to OA is U times AD is equal to OC which is equal to T. So, OC is equal to T plus half Again AD is T times BD we just calculated now, which is equal to A into T. S is equal to U T plus half times A into T square. S is equal to ut plus half at square is the second equation of motion. If you want to know how to write this derivation for your examination, you have to start from this point, then show that the distance traveled by the object is nothing but area OABC, then go for the derivation and substituting all the values. Final value S is equal to ut plus half at square, and it is very important to know that you must draw the graph for your derivation. Next we go for equations for position velocity relation. In the previous classes we have already discussed that the area under velocity time graph gives what? The distance traveled by the body. So here this is the velocity time graph for an object moving under uniform acceleration A. So the distance traveled by this object is given by what? Area of trapezium, that is area of OABC. So this is the shape of a trapezium. You also know that the formula for calculating area of the trapezium, that is OABC, which is equal to sum of parallel lines into perpendicular distance divided by 2. What is the sum of parallel lines? We have two parallel lines, that is OA and BC. Sum of parallel lines OA plus BC into perpendicular distance. So what is perpendicular to these parallel lines? Will be OC divided by 2. So which is equal to, so what is OA here? As we know that OA, which is equal to U, BC, which is equal to the final velocity, this distance BC, which is equal to EO, which is equal to the final velocity, and OC, which is equal to T. Substituting these values in the above equation, so we have U plus V into T divided by 2. Consider this as equation number 1. Next, we have from velocity time relation V is equal to U plus AT. If you rearrange this equation, we have V minus U, which is equal to AT, or if we take T to the left hand side, what you get? V minus U divided by A. So T is equal to V minus U divided by A. Consider this as equation number 2. Substituting T in equation number 1. So 2 in equation number 1, we get S will be is equal to, so I just rearrange this, U plus V or V plus U, that doesn't matter. So I will write it as V plus U divided by 2, and T value we are substituting V minus U divided by A. So this is in the form of mathematical equation A plus B into A minus B, which is equal to A square minus B square. Similarly, it is V plus U into V minus U, so which is equal to V square minus U square divided by 2A. Or if you rearrange this, 2AS, I multiplied 2a with s, which is equal to v square minus u square, or if you rearrange this, v square is equal to u square plus 2as. That is the last equations of motion. So if you want to write the complete derivation for your examination, so you have to start from this point, then calculate the area under this trapezium, that is OA, BC, then substituting the values, two equations, equating two equations, then finally you have the equation v square is equal to u square plus 2as. Thank you.